Hey everyone, and welcome back. Last time, we got our hands dirty with operators. Today, we're taking a giant leap forward. We're going to teach our Python code how to think for itself. Well, okay, not exactly, but we are going to give it the power to make decisions using something called control flow. And let me tell you, this is one of the absolute cornerstones of all programming. So let's just dive right in. So you have to wonder, how does a program actually make a choice? I mean, just like us, a program needs a way to look at a situation, evaluate what's going on, and then decide what to do next. It can't just follow one single blind path. It has to be smart enough to react and adapt to different inputs. Think about it in a really simple human way. Your logic for leaving the house is pretty straightforward, right? If it's raining outside, you take an umbrella. In literally any other situation, or else, you just go without one. It's that simple if this, then that logic. And guess what? That's exactly how computers think. We're about to translate this exact idea into Python. And that brings us right to the fundamental building blocks of decision-making in Python, the if and else statements. Let's break down how this super simple concept becomes incredibly powerful code. Okay, first up, we have the if statement. Its job is really specific and really important. It checks if a certain condition is true. If and only if that condition is true, the code that you've tucked underneath it will run. You can think of it as a gatekeeper for your code's logic. So here it is in action. See this? We've got a variable, age, and we've set it to 20. The if statement then asks a question. Is the value of age greater than or equal to 18? Well, since 20 is definitely greater than 18, that condition is true. Because it's true, Python goes ahead and runs that indented line of code right below it. That indentation is key. It tells Python that the print statement belongs to the if. That's all well and good, but what happens if the condition isn't met? What if the age was, say, 16? With the code we have right now, literally nothing would happen. The program would just end. We need a way to handle that other possibility. And this, my friends, is where the else statement comes into play. By adding an else block, we're creating an alternative path. So now, if we set the age to 16, Python first checks the if condition. Is 16 greater than or equal to 18? Nope, that's false. So it completely skips the if block and jumps straight down to the else block and runs that code instead. See, now our program can handle both outcomes no problem. But let's be real, life is rarely a simple yes or no. What if you have more than just two options? For those situations where you have multiple possible conditions to check, Python gives us the elif statement. And yep, it's just short for else if. Let's look at how this works. Python checks these conditions from the top down one by one. So let's say our marks variable is 75. First, Python asks, is 75 greater than or equal to 90? No, it's not. So it moves on to the next one, the elif. It asks, is 75 greater than or equal to 60? Yes, it is. So it runs the code to print grade B. And, this is super important, it stops right there. It doesn't even look at the else. It only ever runs the code for the first true condition it finds. Okay, we need to talk about something that is, and I'm not kidding, absolutely critical in Python. Other programming languages might use things like curly braces to group code together, but Python, it uses something much cleaner and honestly more readable: indentation. Getting this right is completely non-negotiable. So here's what I mean. The empty space at the beginning of a line means everything. Look at the example on the left. The print statement isn't indented. Python will see that and just throw an error because it has no idea that print is supposed to belong to the if statement. But on the right, with that correct indentation, usually 4 spaces, you're clearly telling Python, hey, this print statement, it's part of the if block right above it.
Now, when you're just starting out, there are a couple of tiny syntax traps that are just so easy to fall into. So let's shine a spotlight on them right now so you can avoid them from the get-go.
Okay, this is probably the #1 mistake every new programmer makes. A single equals sign equals assignment, it's a command. It says, make the variable x equal to 10. But a double equals sign equals is for comparison. It's a question. It asks, is the variable x already equal to 10? If you're asking a question inside an if statement, you have to use 2 equal signs.
Here's another simple one that's so easy to miss: forgetting the colon. That little colon at the end of an if, elif, or else line is Python's way of saying, okay, get ready. A new indented block of code is about to start. If you forget it, your program just won't run. All right, enough theory. We've covered the pieces. Let's put them all together now and use our new decision-making powers to solve a classic little programming problem. Here, we're going to check if a number is even or odd. We use the modulo operator, that's the percent sign, which is just a fancy way of getting the remainder after a division. So num%2 is asking, what's the remainder when you divide this number by 2? Well, if the remainder is 0, the number has to be even, right? So if that condition is true, we print even number. In any other case, meaning the remainder wasn't 0, the else block kicks in, and we know for sure the number is odd. It's so simple, but so incredibly powerful.
So let's do a super quick recap of the new tools in your programming toolkit. You've got the if statement to check your main condition. You've got else to act as a fallback, a catch-all for every other case. You've got elif for when you need to check a whole chain of different conditions. And of course, you know the golden rule: proper indentation is the glue that holds all of it together.
So think about what we just did. We've given our code the ability to make a single logical choice. That's a huge step. But the real mind-blowing power of programming comes from repetition. So the question is, how do we take this one decision and make our program do it over and over and over again? Well, that is exactly what we're going to explore next time.